Hello everyone, and welcome to the next episode of Mr. Grigsby Presents Fun with Math. So what we're going to do is we're going to move on to the next section, 4.7. So let's see what we can talk about here. So this is just to introduce inverse trig to you guys. We've talked about this in geometry. This is going to be a review concept from geometry. Okay, so let's just start with this example here, and let's say we want to solve for theta. Okay, so theta is the angle. Well, what we might want to do is, and hopefully you guys see that we have a right triangle. So since that's a right triangle, what we might want to do is try to set up a trig ratio. That's normally how we solve right triangles and angles and sides and things like that. So let's try to set up a trig ratio. So if you think back, now we have to pick a trig ratio. We've got three to choose from, three major ones. And we've talked about the reciprocals like cosecant, secant, and cotangent. We're not going to pick one of those. Let's pick one of the normal ones, the ones we're used to working with. Sine, cosine, and tangent. So which one should we choose here? Well, the way we determine that is we look to see what sides do we have in relationship to theta. Well, it looks like we have the 3 right here is what side? What's that going to be? Is that the opposite, adjacent, or hypotenuse? Pause for the answer. Yep, it's the adjacent side. And then 8 is going to be the, what is it? Yep, hypotenuse. So, let me go ahead and write this down. So, shoot, I gave it away. Oh well, let me go back here. Yeah, that's the trig ratio we're going to choose because we have the adjacent side and the hypotenuse. Okay? So we probably want to pick cosine here. So it's always the cosine of our angle, so it's going to be the cosine of theta, and that's going to equal adjacent over hypotenuse, which is 3 over 8. Alright, so hopefully that makes sense. So that didn't really solve for theta though. We've got the cosine of theta is equal to that. So guys, what I'm going to try to do here in order to solve for an angle, what I need to do is, well, you might be able to guess just by the title of this section, but let me kind of give you a separate example here just to think about. You don't have to write this down, but what if we had like x plus 3 is equal to 7? Yeah, let's solve that first. So how do we solve this guy? Well, we need to subtract 3 from both sides. This is just to kind of get you to think about this. So x is going to equal, I think, 4. All right, so I hope that's pretty easy. Let's do another one real quick. How about 2x is equal to 12? Well, in order to solve this guy, we've got to divide by 2 both sides. So x is going to equal 6. So let's talk about y now. Why did we choose to subtract 3? And why did you choose to divide by 2 here? Well, you guys might say, well, it's to get x by itself. And that's true. Yeah, we want to try to isolate the variable. Well, the reason why it gets it by itself is because subtraction is the inverse of addition. So if I want to undo addition, I got to subtract. If I want to undo multiplication, I got to divide. All right, so we have to use the inverse operation in order to undo an operation. So let's go back, guys. Cosine is an operation. It's telling us what to do. It's telling us we need to compare the adjacent to the hypotenuse. So if I want to try to undo the cosine ratio of, in this case, if I want to try to undo cosine, just get theta by itself, then what I need to do is take the inverse of both sides, do the inverse operation. Now, whatever you do to one side, you got to do to the other. So here we go. If we take the inverse cosine of that side, and now we've got to do the same thing to this side, inverse cosine. And remember, this is the notation for it. It's not really to the -1 power, guys. It's just notation. I'll write down a different way of writing it as well, because a lot of people get that confused. They think we're actually taking it to the -1 power. No, it just means, that means inverse. Okay. So, guys, when we take the inverse cosine of cosine, those operations undo each other. So we're just left with theta, the measure of angle theta, is going to equal the inverse cosine of 3 over 8. Now, depending on how you have your calculator, if you have your calculator in degree mode, it's going to give you your answer in degrees if you type this in. Let me write this down. Inverse cosine of 3 over 8. Now, if you type it in radian mode, it's going to give your answer in radians. So, now in geometry, we dealt more with degrees. I know we've been dealing mostly in advanced math with radians. All right, we've been converting to those. So let me just do this in degrees, since we've got a geometry example here, just a right triangle. So inverse cosine of 3/8. In degrees, I got my angle to be, as long as you type this in, 67 0.97 degrees. So that would be the answer. So guys, that's why we're going to talk about the graphs of inverse trig functions today, not just cosine. We're going to talk about sine and tangent, the three major ones. We're going to look at those graphs, all right? We're going to look at the graphs. We're also going to talk more about inverse sine, cosine, and tangent. Actually, in this video, I don't think we're really going to get to much graphing. We're just going to try to evaluate a lot of inverses, okay? That's what this video is going to deal with. So that was what we did. Now, so this is another thing to kind of think about. Let's look at this example. So this is another example. For what values of theta will sine of theta equal the square root of 3 over 2? So this has something to do with inverses. I'm going to try to get you into that direction here. I'm going to try to lead you to understanding what inverse sine is. So here we go. So for what values of theta will sine of theta equal the square root of 3 over 2? Okay, so this is the question. Now, I want to try to answer this. Now, I'm just going to go and warn you, there are actually infinitely theta values that we could have where sine of an angle is going to equal square root of 3 over 2. All right, and I'll explain what I mean by that here in a second. So what I want you guys to do is to get out your unit circles. You should have your unit circles out when we do this. I'm going to bring mine up here. And we're going to try to evaluate, we're going to try to figure out what does the angle have to be in order for the sine ratio to be square root of 3 over 2. Okay, so let's think about this. Open. Unit circle. And I'll just bring this one up. Okay, let me make this bigger, full screen. All right, here it is. So, looking at this, we need to think, where are our sine values? Square root of 3 over 2. Okay? Now, remember, when you think sine values, essentially what we're trying to find is the y-coordinate on the unit circle. Okay, so what is the y-coordinate? Where are the y-coordinates square root of 3 over 2 is what we're asking. So if you remember, the square root of 3 over 2 is the biggest important value that I told you guys to remember. Remember, there were 1/2 square root of 2 over 2 and square root of 3 over 2. So for what angles, and guys, there's actually two answers on the unit circle here. I told you there's infinitely many answers, but there's two answers just looking at this unit circle. For what angles is the sine of those angles equal to the square root of 3 over 2, the biggest value? And hopefully you answered here. Oh crap. Let me fix this. Here and here. Okay? So those 2 points on the unit circle are going to have y values of square root of 3 over 2 because those are our biggest y values. Okay? Those are the biggest of the three that we had to choose from. 1/2 square root of 2 over 2 and square root of 3 over 2. The y value here of this point would be square root of 2 over 2. The y value of this point is going to be 1/2. Okay? Same thing over here. Square root of 2 over 2, 1/2. Now, the reason why I didn't go down below the x-axis here, aren't all those y values negative? So that wouldn't really answer the question where the sine values are equal to positive square root of 3 over 2. Those would be negative square root of 3 over 2. Actually down here, 5 pi over 3 and 4 pi over 3. Okay, so our answers, if we just look at the unit circle, the answer to this is going to be, theta is going to be, I'm going to write this answer in radians. So what do we say? Pi over 3 and 2 pi over 3. But those aren't the only ones, guys. Like I mentioned, there's actually infinitely many angles. Now, what I mean by that is all the coterminal angles to those two are going to be as well. Okay, those are going to have sine ratios of square root of 3 over 2. So what I mean by that is if I go back to the unit circle here, if I go around the circle, let's say we start at pi over 3 and I go all the way around the circle again, either direction, it doesn't really matter. Then I would be adding 2 pi. Whatever that angle would give me, I think that would be pi over 3 plus 6 pi over 3. That would be 7 pi over 3. Okay, this one would be 8 pi over 3. Those would be answers that work as well. Okay, let me write those down. So if we go around the circle again, 7 pi over 3 would work. And 8 pi over 3. And we can keep going, guys. We can keep going around the circle in the positive direction and the negative direction. Sorry, I went backwards. Positive direction and the negative direction. Okay, so there's infinitely many answers. So the way to write this down, we take our two answers that we had beginning with in the unit circle. So it's going to be pi over 3 plus 2 pi k. So what that means is, guys, k is going to be any integer. So k could be 1, 2, 3, 0. -1, -2, -3, dot, dot, dot. All right, so k can be anything. So that just means, okay, how many times are we going to be adding 2 pi? How many times are we going to be going around the circle? That's what this is going to tell us. So this is going to be every answer that we could possibly have. This represents every answer. So it's going to be pi over 3 plus 2 pi k. And let's keep going. Let's see. Theta could also be 2 pi over 3 plus 2 pi k. So if I pick that point right there, 2 pi over 3 plus 2 pi k would be an answer as well. Now, so hopefully that makes sense. That's going to be your answers. Those are all of your answers. Okay, those are infinitely many answers because k can be anything. All right. So that being said, like I said, I'm trying to lead you guys into understanding what inverses are. Okay. So before I actually show you the definition of inverse sine, let me keep going here. I'm going to flip past this. And whenever you evaluate inverses, this is what you need to think. Okay, this is the question I always want you to ask yourself. What did my angle have to be in order to get a sine, cosine, or tangent ratio of something? Okay, and that something in the last case was square root of 3 over 2. Okay, so this is the question you need to ask yourself. Now, there's one more thing I want to talk about, and that is how to actually find the inverse sine, or how to limit the domain is what I'm meaning to say. So we need to limit the domain of the inverse sine function in order for it to be a function. And I'll explain what I mean by that in a second. Okay? So first, let me graph the sine function. Okay? So this is going to be something a little bit, let me just, here we go. This might be good to write down as well. So before we move on, if we use a normal trig function, your answer is going to be a ratio. Okay, so remember when I asked, like for example, the sine of 30 degrees. That's going to be 1/2. That 1/2 is the ratio. It's just a comparison of the opposite to hypotenuse. Okay, an inverse trig ratio, your answer is going to give you an angle. Okay, whether it's in degrees or radians. So that's important to know. So you might want to write that down as well. Okay, so now what I really want to get into is, okay, why do we have to limit the domain of inverse sine like I mentioned before? So let me show you the graph of the sine function. This is something that we have graphed before. All right, this was in section 4.4. We're talking about the graph here. So we should have a good understanding what the sine function looks like. So if I were to graph the sine function, it always starts at 0, 0. It's just y equals sine x. It's going to go up. It's going to act like a wave, down, back up. So that's just one period of the sine function. And I could keep going if I wanted to. So right here, this value right here is 2 pi. It takes 2 pi radians for that to make a complete cycle. 2 pi units, you could say. And the maximums, it has maximums at +1, or what I call crests. And then it has troughs at -1 as well. Okay, so it has crests at 1, troughs at -1. Okay, maximums and minimums, you can think of it as that. So that's what the sine function looks like. Now, this is what I want to talk about, guys. Remember when we went over functions, okay? This is all the way back to chapter 1. We used a certain test to determine whether something is a function. And if you remember, we used the vertical line test to determine whether something's a function. So I called this the sine function. So that's kind of a hint that it is a function, but does it pass the vertical line test? It looks like it. Okay, so it's only going to, every vertical line is only going to cross at one place. Okay, and I could have kept this going backwards as well. All right, so that's the sine function right there. It does pass the vertical line test. Now, my question is, does it pass the horizontal line test? Now, if you remember what the horizontal line test tells you, is that it tells us whether its inverse is a function. So hopefully you can see, this is pretty obvious. If I drew my graph like this, it is not going to pass the horizontal line test. Okay, any horizontal line I draw here, it's going to cross more than one point. Actually, infinitely many points if I were to draw this whole thing. So guys, the inverse is not a function if I don't limit the domain. So let me go ahead and try to limit the domain here. Again, the reason I'm doing this is because right now, if I were to graph the inverse of this, it is not going to be a function. Okay? We want it to be a function. So, what I'm going to try to do is I'm going to limit the domain. I'm only going to look at the domain, and I'm going to try to explain this here. I'm going to look at the domain from the first, let's start with the trough on the left here, so negative pi over 2 to that crest, pi over 2. Now what I'm going to try to do is, if I limit the domain here, I just want to graph it from negative pi over 2 to pi over 2. I'm going to erase everything else. Erase this function. And that should be a negative 1, by the way. Okay, got erased. All right, I'm going to try to erase the rest of this from here on out. So if we limit the domain of this function, now here's the question. Does this now pass the horizontal line test? And it looks like it does. Okay, so that's why we have to limit the domain of our inverse sine function. Sorry, let me restate that. I'm not limiting the domain of the inverse sine function. I'm limiting the domain of the sine function. So therefore, I'm going to be limiting the range of the inverse sine function. Okay, so remember, when we do inverses, we switch x and y values. All right, and if we switch x and y values, what we're doing is switching domain and ranges. Okay, so let's go ahead and write this down. So hopefully that made sense. We have to limit the domain of the sine function in order for the inverse sine to be a function. Okay? And now the reason why we limit it to this is because, well, it's going to give us an, let me rephrase that. Sorry, let me think about this. It will give us all the trig ratios that we've talked about. So all the important values. So negative 1/2, negative square root of 2 over 2, negative square root of 3 over 2, positive 1/2, positive square root of 2 over 2, positive square root of 3 over 2. Okay. So here we go. Inverse sine function. Here's what it is. So go ahead and write this down. This is the definition of inverse sine. So it says the unique angle y, and by the way, sorry, before I start reading this, this is another way to write down, this is another way to denote inverse sine. Now a lot of people prefer this way because when you write it as sine to the negative 1 power, that gets confusing. People think that's actually to the negative 1 power. No, that just means inverse sine. Okay? And by the way, on your calculator, to type that in, just type in second sine, okay? That'll give you that. So it's going to be the unique angle y in the interval from negative pi over 2 to pi over 2, such that sine of y is equal to x, is the inverse sine, or arc sine, that's what we can call it, of x, denoted this way or this way. So you can write a sine to the negative 1 power of x, or you can write arc sine of x, either way. Okay? So, pause it there if you haven't gotten that written down, which I'm guessing you didn't. Pause it. And then I'm going to keep scrolling down, so let's talk about this. So the domain of the inverse sine of x is going to be negative 1 comma 1. Alright, so it's going to be the interval from negative 1 to 1. And the range is going to be from negative pi over 2 to pi over 2. Okay? So we can only use values from negative pi over 2 to pi over 2 because if we choose other values for the sine function, then the inverse sine is not going to be a function. We want the inverse sine to be a function. It has to be a function. So if we just type in the inverse sine of an angle, we want it to give us one number and not infinitely many numbers. Okay, so this is y equals sine. So I graphed y equals sine of x. And that was kind of to explain why we limit it. The domain here is from negative infinity to infinity. I can plug in any angle I want in for x. But the range is going to be from negative 1 to 1. This is just the sine function. Okay, so this is the domain of the sine function. This is the range of the sine function. Now, when we do inverse sine, okay, I'm not going to draw the graph. Like I said, I wasn't going to talk too much about the graphs. But the inverse sine of x, the domain here, we can only choose values. So guys, we're going to basically switch the domain and range, but we got to limit the domain of the sine function. So the range is, sorry, the domain here is the same thing as the range there, so it's -1 to 1. I can only plug in values from -1 to 1 here, okay? And the range is going to be, we have to limit it, so the range is going to be from -pi/2 to pi/2. So essentially what I'm saying is we got to limit the domain of sine, so therefore the range of inverse sine is going to be limited. Okay. So let's just do some examples. Okay, I'm gonna check to see how long this video is right now. I don't want to make it too long. So right now we're at 20 minutes. So let's do a couple examples, then I'll make a new video for cosine and tangent. Okay. So here we go. Let's do. Here's my example. Let's do this here. All right. So we're going to find this exact value. So let me write this down. Actually, let me look to see if I have this written already. Here we go. So find, the directions are to find the exact value without a calc. Without a calculator. Okay, use your unit circle to figure this out. Okay, so let's get started with part A here. So if we have the inverse sine of 1/2. Okay, so again, let me go back to this. Let me go back to this one page here where we asked this question. So if you want to evaluate inverse, you need to think this. What did my angle have to be in order to get, in this case, a sine ratio of, and in this case, 1/2. So we wanted to get a sine ratio of 1/2. All right, so let me try to answer this using the unit circle. So the question is, where are our sine ratios equal to 1/2? So another way to say that is, where are the y values of these points equal to 1/2? Well, there's only two answers here in this unit circle. There is pi/6 and there's 5pi/6. Those two. That's where our y values are equal to 1/2. But which one of the, we only want one answer here. That's why we limited the domain of the sine function. So which one of these should we choose? Which one of these is between -pi/2, which would be down here, and pi/2? And hopefully you threw out this answer. 5pi/6 isn't the one we're going to choose. Pi/6 is the one we're going to choose. So the answer here is pi/6. That is our answer. Okay, now let's go over part B. And again, if you have any questions, you can rewind that, you can rewatch that. Let's do part B next. Okay, so if we want to find the inverse sine of -√3/2, this is what throws a lot of people off. Okay, so I want to make sure I'm clear on this. Here we go. This one in green. So if we want to find the inverse sine of -√3/2, again, the question you need to ask yourself is, what did my angle have to be in order to get a sine ratio of -√3/2? Okay, what did the angle have to be? So again, let's go back to the unit circle. Now with -√3/2, our sine value is negative, so therefore our y value is negative, so we got to look below the x-axis. Okay? So here we go. So which angle, there's two up here already, which angles will give us a sine ratio of -√3/2? And hopefully you found this angle and this angle. Those two give us sine ratios of -√3/2. Now, like I said, we only want one answer. So we want to pick an angle, and let me just show you here. We want to pick an angle on this side of the unit circle, because that is the interval from -pi/2 to pi/2. Okay, so we want to choose the right side. So guys, hopefully you can tell, this position is what we're going to need to choose. Now, I do want to make sure everybody's clear on this, because a lot of people write down 5pi/3, they call it an answer, and they get it wrong. Okay, 5pi/3 is incorrect. So we need to change the way that's written, because 5pi/3 doesn't fall between -pi/2 and pi/2. All right, so think about this. If I open up to -pi, so guys, I have to go past pi/2 and all the way around this way to get to 5pi/3. Okay, so it is outside that interval. It's past pi/2. So I need to rewrite this as a negative angle. Okay, I need to write this as an angle in between -pi/2 and pi/2. So 5 pi over 3 we can rewrite as a negative angle. Instead of calling it 5 pi over 3, this is a coterminal angle to that would be negative pi over 3. Hopefully that makes sense. If we went 60 degrees or pi over 3 radians this direction, if we go that same amount the other way, that's the same thing as negative pi over 3 radians. So my answer here, like I said, this is a common mistake, so make sure you're not that person. It's going to be negative pi over 3. Okay, that is my answer. And the only answer. Okay, let's keep it going. Let's do the next one. I'm just going to keep flying through these guys. This one should be a little bit quicker since we did that last one. So the inverse sine of negative square root of 2 over 2. Let me do this in purple here. So which one of these points is the y value going to be negative square root of 2 over 2? Well, if you remember, negative square root of 2 over 2 is the middle value. And I'm still looking down here because we're dealing with negatives. So I've got two options, here and here. Those are my middle values for my y values. So which one can I throw away? Well, obviously I can throw away this one because it's not in the right, not in the right quadrant here, not in the right interval, not from negative pi over 2 to pi over 2 on that side of the unit circle. Now, so this is my position I'm looking at, but can I write the answer as 7 pi over 4? What do you think? The answer is no, because 7 pi over 4 is further than pi over 2. It's outside of that interval. So I need to change the way 7 pi over 4 looks. Rather than calling it 7 pi over 4, what is that the same thing as if you write it as a negative angle? And the answer is negative pi over 4. So again, let me explain. If we go up to pi over 4, that's positive 45 degrees or positive pi over 4 radians. I need to go that same angle the other way, okay? Opening in the negative direction, the clockwise direction. So down here, that's going to be negative pi over 4. Okay. That's the answer there. All right, let's try a tougher one, then we'll call it a day. Okay, this is a little bit harder because we have the inverse sine of sine of 5 pi over 6. So we've got to do two things here. So the way I teach these guys, order of operations. Do what's inside parentheses first. So before you try to take the inverse sine of whatever that is, let's figure out whatever this is. Let's find the sine of 5 pi over 6. And this should be easy. So go to your unit circle. We've had plenty of practice with this. What is the sine of 5 pi over 6 right here? What is the y value at that point? The answer is 1/2. Okay, here we go. All right. So here we go. Figured that out. Now, a lot of people might think, well, this is inverse sine of sine, so shouldn't those cancel out? Well, normally, yeah. Well, I shouldn't say normally. Sometimes, yes. When this angle is between negative pi over 2 and pi over 2. Okay? So if this angle is between negative pi over 2 and pi over 2, then yeah, they would just cancel out and we'd be left with whatever we have here. But this angle is not in between negative pi over 2 and pi over 2, so therefore we need to figure out what sine of 5 pi over 6 first, and then figure out what the inverse sine of 1/2 is. Okay. Sorry guys, I don't know if you can hear that on the camera. Got some critters running around up in the ceiling. You guys know what that's about. I think it's a whole family of birds, it sounds like. So trying to work through this. If you hear a noise, that's what it is. All right, so if we got the inverse sine of 1/2, well again, you need to think, what angle do we have to have in order to get a sine ratio of 1/2? Okay? So let's go to the unit circle. Where are our sine values? Where are our y values? Do this in black, equal to 1/2. Okay? Well, there's two places. I think we've already talked about this. There and there. So which one can I throw out? That's right, 5 pi over 6. And so my answer is pi over 6. And that's an angle that's in between negative pi over 2 and pi over 2. So we can just write it down as pi over 6. That's it. Okay, I'm going to stop this video right here, but that will be a good video to look at, to study for inverse sine. Thanks.